All right, so welcome back. Oh, hello, Alexandre. We have 5 TAs now. 5 TAs, awesome. Welcome back, everybody, to this final hour of the semester. So before we proceed to the quiz game, we are going to just briefly talk about the exam. So the material, everything we've seen, so the slides, the textbook, and any references in the Moodle, the recordings which you can watch, as I understand, times 1.25 or 1.5, like somehow I speak very fast when clicker questions, even though, of course, they are a bit more fuzzy than the exam questions, because the goal of the clicker questions is just to make you think. Practical exercises to program, and theoretical exercises for the knowledge. So all of that is part of the exam material. Now the exam is going to be a computer-based exam. It means that there will be a computer room, either in Ehrlichon or in the main building or in the Gloriastrasse. It's the 3 locations that ETH currently has. The computer is provided by ETH, right? It's not a bring your own device exam. It's really computers are provided by ETH. They will be running Windows as some virtual machine environments. The keyboard is by default a Swiss keyboard, but if you want, you can ask for a US keyboard. And if we have enough keyboards compared to the request, then we can accommodate. So the poll is already out, I think, or already out. So you can just add your name to the list if you would like a US keyboard. Knowing that even if you don't have a US keyboard, you can still change the logical layout on the machine, right? So for anybody who doesn't watch their fingers when they type, you can always change to even French or any layout you want. That is available on the exam machine. Now on the exam machine, you will have basically the exam in Moodle. It's a Moodle environment, so all the questions are in Moodle, and we grade what is in Moodle. Every answer you enter in Moodle. So a lot of multiple choice questions, some questions where you need to enter some text, and then some query questions when you have to write some queries. And in order to write the queries on the same machine, you will have an installation of PostgreSQL with tables pre-populated. The data is already going to be in there. You will have PySpark, so the pre-installed. You will that includes Spark SQL. You will have RumbleDB, which supports JSONic installed. And the interface with all of this is Jupyter Notebooks. So on exam day, you just click. There's a few icons at the bottom. You click on the icons to open everything. And then in the Jupyter Notebook, you will have pre-existing queries that are in there. And you can just click to check that it all works. And that's pretty much to get you started. And then you have blank cells where you can enter your own queries, right? So the data sets will already be installed. It will all work, and all the machines are exactly the same, maintained by ETH. If there's any technical problem, you can raise your hand. We'll note down the time, so we credit you back any time lost if it's an extended period. And then there's technical people who will come. So first the TAs, but we also have technical people in the background. They can restart the virtual machine. They can restart the machine completely. In the worst case, we can move you to another machine, even though that's in that case, it's a bit more stressful, so we try to avoid. But basically, there are people to help you. So the one important thing is to raise your hand, so to make sure that we freeze the time individually. So it means that you don't have to worry about the installation. So even if you have trouble with your laptop, on exam day, it's all maintained by the digital exam team. In terms of programming, you will have 4 sections with programming. The first section is with PostgreSQL, so writing SQL on a relational database. The second one is PySpark, meaning that you process RDDs and transform them with Python and Spark. The third one is Spark SQL, where you have some structured data set in JSON that you can read as a data frame. Then you can write Spark SQL. But if you prefer, you can also write data frame transformations. That's fine too. Nobody will complain. And finally, JSONic. So these are the four. The data will be given to you in advance. Actually, it's the same data we've used already in previous exams. So you can even train yourself in advance with exactly that data. There will be no surprise on exam day. The Jupyter notebook that you will have on exam day, we also show it to you in advance. So here too, there is no surprise. You will come to the exam day and see exactly what we told you there will be. We will release an updated exam environment soon, but it's pretty much just the same you already have, just with a few updates to the latest versions. Right now, the only deal we have is that we have a syntax highlighting. We are trying to bring you syntax highlighting with JSONX, which is implemented, but somehow it doesn't quite work. So there is somebody on it. And yes, that's basically the exam. Does anybody have any questions regarding the exam? Anything that worries you or that you want to know?
On Zoom,
Yeah.
Edward asked about MongoDB.
Not as practical questions. We can ask questions, but not with programming. You will not have to write MongoDB code, or there will not be any MongoDB installation or any MongoDB data. Right? But we could ask you questions. We could show you some MongoDB queries and ask questions on that. By the way, we share past exams, right? We share many past exams, so you can even see how it looks like when we do that, right? I saw there is also a question on the chat that I'll process just after that. That was during the break. Any other questions? Now is the moment, right? Okay, so that's it for the exam. So of course you can still ask questions later, right? We are still on the forum and by email. All right. And so the question, so somebody mentioned they have issues with reading the JSON file in exercise 11. Does it happen to anybody else? Yeah, I see raised hands. Okay, maybe we'll take a look, or the TA team can take a look, and maybe you know.
Yeah, I mean, we also see other students seeing the issue with the JSONic, so we will extend the deadline of the quiz by a week, and then we will look into those issues.
Oh, that's the JSONic one, right? So that's the
Yes.
one we discussed. Okay, that's not another one. Okay, so indeed, Docker. So the goal of Docker is that it just works on every machine, and we have many less errors than a few years ago when we were not using Docker, but it still happens once in a while. It seems to be the M3, the Apple Silicon M3 has issues, but I think you said 2 people on Windows too. So what we're going to do is we'll investigate it. As you said, the deadline is a bit extended to give more time, and also it's also interesting for us for the next semester that we identify a few errors and find how to fix them, because that's useful also for the future cohorts. So we'll help you and give more time for the quiz. There are like 3 questions, no real answer of any TA. Yeah, they will contact you, or you can, don't hesitate to ask again otherwise.
Just, oh yeah, I want to ask, is there one last exercise coming, or
is there any exercise?
is there like one more coming for the on Moodle, or are we done?
One more
them?
quiz or one more?
Yeah, one more.
Yes.
Okay. All right. Thank you.
So 25 in total, as many as the 001 points. Okay. And yes, so if there are questions in Moodle with no answers yet, this is being discussed. So just because there's no answer yet doesn't mean that nobody is looking into it. There's active discussions right now on the TA channel on how to proceed. Right? Okay. So now the quiz. Who knows? The TV show Eiskake 100. Some of you, right? So you basically have the audience, everybody is in the game at the start, and then there's questions, and then when you get one wrong, you have to sit, right? So and then at the end there is one winner. But in France, there is also somebody playing against the audience, and now we have the wonderful TA team today who is going to play against you. So what's going to happen is that at the start, everybody is going to stand up. So now you can all stand up if you want to participate, of course. So everybody stand up. On Zoom, we do it with raised hands. So you can all raise your hands so that we know that you are playing. So everybody who wants to play, raise their hands now. Very good. And then I'm going to ask you questions on Clicker. You can answer with your phone or laptop. Now, we don't have all the environment that would allow us to check everything. So this is all based on trust, right? So I'm going to, every time we have a question, we trust you that you will sit down if you got it wrong. And that usually works very well because it's not like there is a trip to Hawaii at stake. It's at stake. It's a few sweets here. So usually trusting works well. So every time you will answer, and then we'll try to time that with the TAs. That the TAs will give their answer. You can do that, I think, on the chat room or something. You have a way to do it. The trick, the difficulty is to manage to record the TA answer without after having disabled the clicker to avoid the change. So yeah, but we'll make it work. All right. I'm going to switch the screen. I have to find the right window because I have a lot of windows. There you go. Okay. So some questions you might have seen before, some others not yet. So let me go a bit at random. What do MapReduce 2 and Spark have in common? Everything. They are the one and same technology, or they both have a processing model based on fully generic directed acyclic graphs, or they are all based on yarn, or their input and output model is more flexible. Records do not need to be key value pairs. So for the first question, we can give a bit more time so you can make it work. So you know there's a web app that you need to go to. I think it's eduapp.ethg.ch, the address. eduapp.ethg.ch, eduapp.ethg.ch. And even if you don't manage, you can record it in your brain. And again, we trust you. So now, have you recorded your answer somewhere? Okay. So I'm going to stop here.
Yes, we said it's C.
You said it's it's recorded somewhere. We can check. It's in. Oh, it's in the TA team chat. Yes, exactly. So I can see, and right here, that's I'm connected here. Exactly. I can see that you say answer C. Yeah. So, all right. So now, what happens is that if you got it wrong, you can now sit or lower your hands, but you can still continue to answer. You're just no longer running for the winner prize. but you're still, you can still participate and give answers and so on, just because it's fun and we're all practicing together, right? So do not hesitate to continue to enter your answers. So now, here's another one. That I think we saw during the lecture. HBase runs on top of HDFS. But HDFS is slow, right? It has some high latency, right? So how come then that HBase is nevertheless fast in spite of running on top of HDFS? So first, maybe it's not faster. It actually has a high latency like HDFS, or because HBase has key values in the mem store as well as caches, or because it short circuits data nodes, or because it uses smaller HDFS block sizes of 64 kilobytes. So it changes the parameter of HDFS to 64 kilobytes. Okay, so I'm going to show the answers. So there are two correct answers, and I can see on the TA team that the TAs got it right. So indeed, we cache, so there is a lot of that information in the memory. So the mem store contains the key values that are recent, fresh, that have not been yet persisted to HDFS, and the cache contains some local copy in the memory of key values that have been persisted to HDFS. So that accelerates a bit. But most importantly, we short circuit the data nodes. Do you remember that what it means is when you freshly wrote values, key values to HDFS, you have one copy, one replica of the corresponding HDFS blocks on the same machine. So what you do is you read and write to and from the local disk, right? So this is the reason why it's so fast. You don't even bother to go through the name node or anything. You just read and write from the local disk. It might not always work. So in some cases, you might need remote reads. But most of the time, and when the system is in cruise mode, there's going to be a lot of local read and writes. So this is the reason. So congratulations to the TA team and to you who gave a correct answer. So we have now a few people surviving. Yes. No, in the exam it's only one. Yeah, it will. I don't think it will let you. But having said that, that's for the what's called a single choice question, that you have only one answer correct. But you also have questions at the exam that are called multiple true false, where you have a series of statements, typically 4, but it can be 5, 6. And for each statement individually, you need to say true and false. And of course, in these questions, it might be that several of them are true and several of them are false, right? But this is individual. For every statement, you say this statement is true or this statement is false. Does it make sense? Yeah, awesome. But for the single choice questions, there's only one. But in a single choice question, you see it because there's only one box for every question, and you are forced to pick only one. It will not let you pick several. All right. So we have, if I count, I'm very bad at counting, right? But 1, 2, 3, 4, 5 in the lecture hall and 3 on Zoom. So we have 8 students still competing for the winner prize. So let's go maybe to something that we actually did not go into that much in this lecture, but again, that's not the exam, that's just a quiz. So there is something known as tail latency. I think it was briefly discussed. What is tail latency? There is a paper contributed by Jeff Dean on this. So is it the latency required to write the last block of a file to HDFS? Or is it the latency of a point query or the latency of a range query? Or does it describe the behavior of parallel computation at very large scales when there is a probability of almost one that some nodes will take significantly longer? So I see that the TAs have recorded their answer. And the correct answer is D. It's the idea that if you have many nodes, for some reasons, there will always be some of them that take forever. And that's something you just cannot fix. You cannot write faster code. You cannot do anything about it. And there are tricks. One of the tricks is to to basically have every task executed by 2 slots. And then whoever finishes first, then you cancel the other. Another way to do that is to launch the tasks on the slots. And when there is something that takes forever, like you can measure that in percentiles of time, right? So when you are in the worst 5% of performance, for example, then you just launch the task again on some other nodes, right? So this is something that works quite well in practice. But basically, it's called tail latency. And that's something that you would see in very large companies. That is not everybody has enough resources to run into these problems. All right, so now we have 1, 2, 3 in the lecture hall who are still in the competition. And on Zoom, 3, so that's 6. So here's one. How does a document store, like MongoDB, store documents physically? As text files, JSON, on top of HDFS, MongoDB queries are automatically converted to MapReduce or Spark queries. Answer A. Or answer B, as an optimized binary format BSON on the local hard drive, JSON types, arrays, and objects are efficiently stored and basic atomic types are supported. Or as text files JSON on the local disk, and they are parsed on the fly with a technique called just-in-time parsing. Or answer D, crowdsourcing. There is a document center under the Antarctic in a secret base where little elves store and retrieve documents on paper, nicely sorted on shelves, organized in racks. The secret base actually exists. We use the elves in information retrieval in the other lecture for the omega space for our probabilities. So I see a recorded answer on the TA team chat. And the correct answer is answer B. It's BSON. That is a proprietary format. It's not a data lake, right? This is where, when I said it's like PostgreSQL, you cannot control the way the data is stored. It's entirely handled by the system. And BSON is the name in the case of MongoDB of what they are doing. But as a user, you don't see BSON ever. The first bullet point actually would be a kind of RumbleDB, right? RumbleDB implements JSONic in this way, but MongoDB uses this optimized binary format. Not as optimized as Parquet, right? Because in Parquet you have schemas, but in BSON you don't have schemas. It's really just a compressed version of JSON. So now we have 2 survivors in the lecture hall, and on Zoom 3, still 3. All right. So what can I ask now? Among these formats, one of them has a data model that is considerably different from the others, and it's particularly well suited for the publishing industry. Which is it? Avro, JSON, Parquet, XML. So I have a recorded answer from the TA team. And the correct answer is XML. Indeed, XML is quite different with elements, attributes, and so on. The others, in fact, JSON, Parquet is basically valid JSON. It's compressed and optimized valid JSON, and so is Avro, right? So it's very similar models. But XML is very different. But it's very heavily used by the publishing industry because you can basically store scientific papers or books or texts with tags in the middle of the text. All right, so we have still two students in the lecture hall. And on Zoom, 2 people left. So we have 4 still in the competition. So now, do you know why Hadoop is called Hadoop? Was it randomly produced with a password generator? Is it a distortion of addup because of the reduce part that adds up the values? Is it a reference to an episode of The Simpsons with a lot of donuts? Or is it named after the elephant toy of dog cutting son? All right. So the TA team recorded their answer. And indeed, it is the elephant toy of dog cutting son. Dog cutting is the founder of Hadoop. Hadoop is basically the open source version of a few technologies invented at Google. But this was at Yahoo when this was on it. Dog cutting would be the Yahoo employee who back then created Hadoop. Wow, so we have 1 survivor in the lecture hall and 2 on Zoom. Are you still here on Zoom, by the way, just to make sure that you're still here? If you just hand down and back up, just to check you're still here. Yes? Both of you? It's only one move. Both of them, that's okay. So you're still here. So we have 3 people. Awesome. All right, so let's continue. What is the issue with assigning 1 task to each slot in MapReduce or in Spark? Answer A, some tasks may take longer, so that most slots are going to be idle waiting for the next ones to complete. Or there are no issues. You can do that, it's commonly done. Or all slots are busy and not available for starting with the next phase, which leads to non-optimal performance. Or if a task fails, the whole Spark job fails, a task should be assigned to 2 or 3 slots for fault tolerance, at least. The TAs have recorded their answer. And the answer is A. Indeed, if you have 1 task per slot, they will not do it at the same speed, and then everybody is going to be waiting for the slower slots. So this is why we have more of them. And then dynamically, when a slot is done, they will take the next task and handle more of them. All right. So we have the two competitions still ongoing, right? There are still 3 students in the game, plus the TAs also have a streak of correct answers, but we still have a bit of time. What is the highest Hadoop version released? I think it was last November, not last March, but what is the highest Hadoop version? I'm going to time it because I know you can look it up. So 2, 10, 1, 3, 2, 2, 3, 4, 1, 3, 1, 4. I'm going to stop in 15 seconds. 10, 5, 4, 3, 2, 1, 0. Oh, one close. Yeah, 3, 4, 1. You said D, right? You said 3, 1, 4. Yeah, you're out. So the students collectively won against the TS. I warned you, right? These are good students. Very, very tough to win against. All right, so the students won. And now for the students still in the game, still three of you. All right. So a big applause to the students, maybe from the TA team instead. All right, but we still need now to find a winner among the students. I think the internet connection is here. Right, so select the correct statement. In HDFS, files are sharded in partitions called blocks or replicas. That's the two possibilities. Replicas or blocks are redundantly stored, and each copy of a replica or block is called a block or a replica. Blocks or replicas are ranked, and the first one is called the main block or replica. So you need to select the one that is correct. And the correct answer is this one. Sharded in blocks. Blocks are redundantly stored, and each copy is called a replica, and there is no such thing as a main replica, right? We just have 3 replicas, even though there is an order when you save them, right? That the first one is on the same machine, but then you don't remember which one was the first, right? So, all right. Do we still have the 3 students in the game? Yes, absolutely. So now we need tougher questions, right? Maybe we also need to time the questions. So maybe this one I will time. 10 seconds. This document is well-formed, valid, both neither. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. It's only well-formed. We cannot say it's valid because there is no schema, exactly. So it's well-formed. We have 2 people left then on Zoom. So we are going to find a winner, one of you two. The only thing is that, you know, I had some sweets here, and I don't know how to send them on Zoom. So maybe with a 3D printer or something. But I think the sweets we can share them because you want the students. And then if you want to, whoever wins wants to collect more sweets, we can also provide some sweets for you later. But for this, you have to win. So let me find another one. This one, I'm timing now, right? So 10 seconds. Which of the following syntaxes is not suitable for TRILAC data? CSV, JSON, XML, YAML. 7, 6, 5, 4, 3, 2, 1, and CSV, 100%. 2 of you are still here. All right. What is the region in HBase? 10 seconds. A single interval of rows, a set of intervals of rows, a single interval of columns, a set of intervals of columns. 3, 2, 1, 0. Ah, nobody got it right. So now I see the hands should be going down. Yes, exactly. And now, because we need a winner, so now you can put your 2 hands back up. That's the rule, right? There has to be one winner. So now you can, the both of you, right? Exactly. I will continue. In 2014, Spark broke the gray sort record. How much time did it take for them to sort 100 terabytes of data? 34 seconds, 1.4 minutes, 23 minutes, or 3 hours? All right, 5, 4, 3, 2, 1, and 0. It's 23 minutes. We have a winner confirmed. Addis, yes? We have a winner. Okay. So now, I don't know if you hear the lecture hall, but we are going to have an enormous round of applause for Addis, who won this semester the Big Quiz Games. So congratulations to you. If you can have a prize later, if you can come to CAV or SCF, and we'll organize something for you so that you have a prize. But the sweets right here, we are going to share it across the room. So again, congratulations, Addis. This is the end of this semester of the lecture material. It's always a very particular moment. Thank you for being such wonderful students, for the interaction. Thank you to the wonderful TAs who contribute to this course and are there for you in the daily life of the course, doing a wonderful job. Again, an applause for the TAs, I would say. That's the day of the So what's going to happen now is we are going to release past exams. We are going to release an upgraded exam box with the exam, what we call the cheat sheet is basically the Jupyter notebook you get on exam day. We are going to be here. You can continue to ask questions. I think Moodle, the Moodle forum is the main part. So we will be there to answer your questions. Do not hesitate. Remember that there is Ethel. Who is using Ethel? Some of you, right? So Ethel is a chatbot here at ETH that read the entire textbook, and she can answer your questions. So do not hesitate to interact with Ethel. The address is ethel.ethz.ch. And I think Ethel now is also the first name of the oldest lady on the planet. Is also called Ethel. So use it, but of course we are here too, right? There's the AI, but there's also the TAs and me, so you can also ask your questions. So I guess I'll see you at the exam in August. Thank you very much for the semester. Enjoy the rest, so the exercise session this week, and get some good rest also during the summer. Thank you very much, and goodbye.